So let's go ahead and take a look at these functions here. They have an a and they have a h. So let's go ahead and graph it and see what happens. Well, we have y is equal to 1/2 times the square root of x minus 1. So that means that we have a positive, we have a real square root when x is starting at 0, right? So we'll do 0, 1, 2, 3, 4, which means our domain is going to be x such that x is greater than or equal to 0. And then we need to go ahead and work it out, right? So when x is 0, square root of 0 is 0, so 0 times 1/2 is 0, so y will be equal to -1. When x is equal to 1, the square root of 1 is 1, so we'll have 1/2 minus 1, so it'll be -1/2. And then 2, that's where calculator needs to come out. It's 1/2 times the square root of 2, that's 0.7. And then we have 1/2 times the square root of 3, that is 0.87. And then for 4, it is 1/2 times the square root of 4. Oh my goodness, I was supposed to minus 1 on all of these. So this is going to be, this is actually going to be -0.3. 0.3. And this one is going to be -0.13. Okay. And then 4 is actually 1/2 times the square root of 4 minus 1 after putting it in calculator is equal to 0. So now we can go ahead and graph it. So we got 0 is going to be -1 down here. Our 1 is going to be -1/2. Our 2 is going to be -0.3. Our 3 is going to be -0.13, and then our 4 is at 0. So you can see here we have this squished down version of the parent function, right? It's squished down by half or so. And it's also shifted downward on the y-axis by 1, right? So our domain is x is greater than or equal to 0, and our range, or y, is going to be y such that y is greater than or equal to -1, right? And so how do we compare it to the parent function? Well, the graph is squeezed vertically and shifted down by 1, right? So that's what having our a become a fraction does. It squeezes the parent function vertically, and then if a is greater than 1, then it stretches it out vertically, right? So let's go ahead and take a look at this one over here and see what happens when we have a -a. That's going to reflect on the x-axis, and if we have a negative h value, then that should move it to the right by 3, right? So let's go ahead and work this out. So what should we start our x values at so that our radicand is a positive number? Well, our x is going to have to start at 3, because if it's any less than 3, then the radicand becomes negative, right? So we'll do 3, 4, 5, 6, and maybe 7. So on 3, the radicand becomes 0, so square root of 0 is 0. On 4, our radicand is 1, and square root of 1 is 1, so it'll become -1 because we have a negative sign on the outside. And then if we have x is 5, we get 2, so square root of 2 is 1.41, so we'll get a -1.41. And then a 6, it'll be the square root of 3, so then it's going to be -1.73. And then for 7 minus 3 is 4, so square root of 4 is 2, so it's going to be -2. So let's go ahead and graph it out. We got 0, x is 3, and then y is 0. It's there. X is 4, y is -1, x is 5, y is 1.4, then 5, 1.7, and then at 7 it's 2. So we get this version of the parent function. Right? So what's the domain? It's all x such that x is greater than or equal to 3. And what's our range? Our range is y such that y is less than or equal to 0. Right? And how do we compare to the parent function? Well, the graph is reflected on the x-axis and translated, let's say, translated to the right. All right. So there we go.